Okay, so quick reminder, you can in fact sit on the front row and you won't die. So that's just a little tip between you and me. So apparently you feel that you will in fact die. Okay, well, I'm going to work on that. Lee, I'm going to let you.
Awesome. Thanks, Jess. How's everybody doing? Let's try that again. How's everybody doing? There we go. Hey, we've got some exciting stuff happening this year. Who's heard about the FinTech Accelerator we're doing with FIS? Awesome. We're really excited about that. We're going to have 10 FinTech financial technology companies join us in May for a 15-week boot camp. What that means for you is over the summer, we're going to have some really cool technology leaders come in to do some lunch and learns and some codits. We've got the head of payments for FIS. Who knows who FIS is? Let me start with that question. Everybody knows who FIS is. Great. So we've got some really cool tech people that are coming in. Randy, raise your hand. Randy in the back has done a couple of codits already. He's going to do a lunch and learn for us in a few weeks talking about real-time payment transfers and how the Fed is trying to speed that up. So that's going to be a really good talk. Jess is going to recap our hackathon and stuff in a second, but what I do want to mention is the Venture Center is focused on supporting the dev community just as much as we are the entrepreneurship community. So we did a hackathon a few weeks ago. It was awesome. She's going to explain that. We have Code It, which is at least once a month, where we are going to start getting a little bit more edgy and raw, and we're going to debate the finer points of, you know, why Scala, why not Scala, and really any sort of topic that you all bring up. And then the lunch and learns are going to be a little bit more professional. So you're not going to see beer and pizza at a lunch and learn, but we will have box lunches. The lunch and learn will be something that you can send the flyer to your boss, your CTO or whatever, and more likely to get them to kind of encourage that. So we're going to try to, through those 3 different angles, really grow this year. So real quick, Andrew, grab a mic, come join me. I want to introduce Andrew Lewis to y'all. Andrew is a senior at UALR, a non-traditional student, and he started yesterday, as our hacker in residence. How's it going?
It's going good.
Awesome. So Andrew, why don't you share your background with these folks? Cliff Notes version, though.
Well, as Leif said, I'm a senior. I study computer science at the University of Arkansas at Little Rock. I have been a developer on 2 of the hackathons, the 2 that have been hosted here, as well as competed on a national and international level of capture the flag and cyber defense competitions. So Lee mentioned DevOps and being able to provide not only the entrepreneurship but the DevOps portion. That's kind of a role that I feel like I've been brought in for.
So when he says the national competition, what he's not sharing is the students from UALR not only compete in national code competitions, but they actually build them. And when they do compete, they win. So what was the last couple competitions that you guys won?
Well, we won 3rd place in the regional Southwest Collegiate Cyber Defense Competition. And what that is, it's a place that's top 30 in the nation. It's a competition sponsored by Raytheon where we have a team of hackers trying to attack us, and we have to basically support an entire network as well as set up and fix what they've broken.
And once a month, you've got this other gig you got to go to with the Navy. So what's your role with the Navy?
With the Navy, I do analytical work. I'm in the Navy Reserves and support CENTCOM. So 1 week in a month, 2 weeks in a year, I go and provide analysis on.
And that's intelligence. Military code word for intelligence. So one of the cool things that Andrew and the students from UALR did for the competition is they built some pretty hard puzzles. Now, what was really interesting, we had a lot of the puzzles were related to network and infrastructure, and we had a network and infrastructure company they sent a team of 4, and they did not place very well. And we had a Fortune 500 company sent 4 teams. They did much better, but they didn't take home first place. And I'm not going to steal the thunder from Jess. She's going to explain that. But what I thought was really cool is we've got students from ULR building technical puzzles that the industry is having a challenge with. And it doesn't necessarily mean it's a skill gap, but it's how we approach problems. And so a lot of the content that we cover in the Code It series and the Lunch and Learn is going to be how we look at solving new kinds of technical challenges and sort of getting out of the day-to-day headspace that we have. And Andrew's going to be helping out a lot with that. How do you find out about this stuff, and how do you suggest what you want to hear? There's email. Who got an email for tonight? All right. Who got a meetup? And who got an Eventbrite? And then some of you got Twitter or social media, right? So it's all over the board. You can engage with us through any of those channels to suggest, I want to hear about a particular tool or a technology. I want to hear from a particular person or a particular company and a product evangelist. We want feedback from you all to figure out what to plan. Andrew's the one that's going to be taking those requests and getting it scheduled, and then informing everybody about sort of what's coming up. So we also have a Slack account. So if you visit venturecenter.slack.com, you can actually just sign up or request a link, or if you have trouble, let one of us know and we'll get you signed up for that. We've got several channels inside of Slack where we're talking about Codits and the Lunch and Learns, and some of the other dev opportunities. We have some classes coming up that are going to be cool. We'll talk about later. And we've got 2 Lunch and Learns with IBM coming up. We're going to have a researcher from the Watson project talk about the art of the possible with cognitive computing. And then we'll have a couple of Lunch and Learns around DevOps. So we're going to keep Andrew busy. We've got a lot of cool stuff coming on. And now for those that haven't met Jessica is our Director of Programs, meaning she's the woman in charge. And she's going to talk about the hackathon.
Okay. So I don't want to get too far into the time, but just for the record, isn't this beautiful? Isn't it? Wouldn't you like to know that your name was on here? And did you know that the team that is on here on the first slot will also be the team that will be on here on the second slot? Because the Space Goats, 2 of whom are sitting over there, don't look at them. They seem shy. Anyhow, Space Goats took home their second title. The really interesting thing, and I think it's good to note as far as up-and-comers in Arkansas, the interesting thing is that in our first hackathon last fall, the Space Goats beat out, but only barely, a team from the Arkansas Math and Science School. This time, they beat out, but only barely, a team from Catholic High. So, and you guys are professionals. I mean, now that's not knocking them in any way. It's just the point is, the other way to look at it, they won, and then there are high school students, and then there's everybody else, right? I mean, you know, directors of IT things, and that's a challenge. Yeah, no offense to the Space Goats, but some of you guys need to come and kick their asses. So, oh, it's theirs. Yeah. Stellus is gonna win. So anyway, okay, well, I don't know if you guys know this or not, but this is a technical talk series that we do generally on the 4th Tuesday of every month. Today is going to be the awesome Elizabeth Childers, and we are going to cheer for her when she comes up here because she might be a little nervous and we don't want her to die. So there's that. Coded is also sponsored generously by Mainstream Technologies. And so I'm going to, yes, yay to Mainstream. We'll clap for you some more. So, okay. But I'm gonna let Johnny Burgess, who is one of the co-founders of Mainstream, introduce Elizabeth and kick things off. So welcome him. Woo!
Thank you, Jess. Mainstream is very proud to be associated with Coded as a prominent software development IT services company here in town. We feel it's part of our corporate citizenship responsibilities to be connected to the community here, and we're a bunch of geeks, so we really enjoy these talks. Our subject tonight, big data, I remember 20 years ago when my boss would tell us to write more stuff that generated data because DASD was cheap. Who knows what DASD means? Okay, for the 75% that don't, DASD means Direct Access Storage Device, or 1990s speak for disk drive. So for 20 years now, we've been struggling with generating this data, and now that we finally succeeded in generating all this data, now we got to figure out how to analyze it and do something with it and turn it from big data into big information. And our speaker tonight, Elizabeth Childers, has been doing that since before it was called big data. She spent 16 years at UAMS analyzing everything, any kind of data that they were pulling out of any of their patient interactions, especially in the areas of human behavior. She's been trolling through that data, trying to uncover trends and get insights out of that data. 6 months ago, she jumped into the private sector, where she's the director of financial and statistical analysis for a large, prominent retailer headquartered here in town. She is the real deal, and I know you're going to really enjoy her presentation tonight. So without further ado, Elizabeth Childers.
All right, so one of the things we want to do is we want to really amp that up. So everybody standing up and give a big cheer to Elizabeth Childers.
Thank you very much. I also want to say thank you for the beer. It's making things a lot easier. So I'll go ahead and get started. Thanks everybody so much for having me here today. Hopefully I will share some information that you don't already have. I'm super nervous. I'm a huge advocate of sharing information, so I just want to really put that up there and let you guys know that I'm super nervous. I was talking to my friend the other day, and I was like, why am I so nervous about this? I give talks and lectures all of the time. I'm a professor, this is what I do, but I give talks on statistics, and that's kind of the end result of big data. I don't really ever talk about this part of it. So I think really that's why I'm nervous. So this is kind of like the debut of big data for me. So hopefully I will be able to share some information with you guys that you didn't already know, but I'm in a room full of giant geeks, which I'm starting to learn. So hopefully I'll learn something from you guys too. But I've always been told if you start a presentation off and you're really nervous that you should probably tell a joke. So I really only know one, so I'll share it with you. And it's probably the geekiest joke that you'll hear for the rest of your life, but here it is. There are two atoms sitting on a log. One atom says to the other atom, "Man, I think I've lost an electron." He says, "Are you sure?" He says, "I'm positive." That was hilarious. That was hilarious. I'm just glad y'all got that. I'm so glad. Okay, so a little bit about me. I know John has just told you guys. I have been doing epidemiology. I've been in the healthcare industry for the better part of 2 decades. I've been doing epidemiology for quite some time, looking at human behavior on a lot of different levels. And so mostly with regard to outcomes of diseases, symptomology, and stuff like that. But really how people's behaviors influence different outcomes on a ton of different things. But in the last 6 months, 7 months, I've decided to take all that information and see if I can apply it to a different aspect. So how people are taking behavior and, am I doing something wrong with the computer? No, is it you? Are you doing it? You're breaking it.
It decided to pick this moment to have a little seizure.
Perfect. That's exactly what would happen to me. Leave it to me.
No, it is behind you.
Oh, okay. Well, good.
You have options.
All right. Okay, well, good. As long as y'all can see it, that's fine. No, I don't have to see it. So I've decided to take that information that I've been using for the past 16, 18 years and see if I can apply it to retail practice. And with that, what I mean is, how does human behavior influence the trade market or the marketplace or even buying behavior, migration patterns, things like that. So that's kind of currently what I'm doing. So really what you're here today, I think, to learn about is what exactly is big data. And so I kind of like to simplify things pretty simplistically, I guess, just for my own mind. And so you and I are data processors as human beings. We process data all of the time. Did everything break?
Yeah, it's all right.
Okay. So we process data like computers, kind of, as human beings, right? So as you are driving down the street, we're processing information constantly, all the time, when you're awake and when you're asleep. If you're driving in your car and you see a light change from green to red, you have to make a lot of different decisions based on that interaction alone. So, should I run that red light? Is there a cop around? Is there a pedestrian walking the street? What are the consequences if I decide to run that red light? Am I going to get a ticket? Am I going to cause a car accident? Is absolutely nothing in the world going to happen at all? You're processing all of that within just a millisecond, right? Well, computers do exactly the same thing, but on a different kind of scale. But how badass would it be if we had the ability to process more of that information on a bigger scale? So like if our brains could process more information on the street. So how many people are walking on the street? How great would it be if we had an extra brain on the other side? Just tack on an extra processor. And then when that one got full, tack on an extra processor. Tack on extra brains, right? Well, big data kind of works like that. It's just an oversimplified way to say it. But really, that is kind of what happens. Where do I go from here? I'm totally lost.
So you get this.
Okay.
And you'll be able to see
Great.
what you've got.
Super.
And yeah, now I'm not really sure what's happening at all.
Okay,
So
that's
it's going
okay.
great. Now I'm nervous.
Don't say that, because if you're nervous, I'll get nervous. There's beer. There's more beer.
I'll set up a collection jar in the back.
Seriously. So data experts or big data experts like to use 3 V's. Some people use 4, some people use 5. I use 3. Volume, velocity, and variety. So volume means there's a ton of it, and it's coming at you at a huge rate of speed, and there's different types of it. Did I not do that? Okay. Oh, yeah, good. Sorry. So there are different types of data. So my best friend in grad school has been preaching to me for years and years as a qualitative analyst that I should be, at some point, willing to swallow the pill of analyzing qualitative data. That's not the way I operate. I can't stand it. I hate it. I like things that fit into a box, very structured like, very traditionally, and are very easy to read. I like that. It makes sense. She's the kind of person that analyzes data. She walks up to people and is like, how do you feel about that? Tell me how you feel. And she puts it into a story form, maybe an email, draws a picture about it. She just analyzes things very, very differently from me. That's very unstructured, very non-traditionally. Well, I care about how they feel. I just care about how they feel on a scale from like 1 to 7, so I can put it in a box. And then there's another kind of information that is kind of a new buzz term that a lot of people use, and it's called the Internet of Things. I'm sure most of you have heard of this already, but I like to call that machine data. And that's becoming huge. It's probably going to overtake the other 2 types of data within the next several years, probably pretty easily. And that's the information that's coming from contraptions like your phone. GPS is coming from your phone. Information that's coming from engines from an aircraft carrier, engines from an aircraft, the black boxes from an aircraft. They're producing a terabyte every single flight. And that's a lot of information, a flight. That's just an example. That's really big data. These can be mutually exclusive or inclusive on whatever platform. So I feel like nothing's working. Okay. Okay, so where does big data come from? It comes from a number of different places. I just thought I'd list a few here. Google, Twitter, Facebook, YouTube, LinkedIn, Amazon, shopping. Everything you do on a daily basis is captured on some level in some way, especially if you're touching a computer. If you go shopping, if you decide to go to a brick and mortar store and buy a pair of shoes, let's say, I don't know, you go to the mall. Someone pick an amazing store at the mall. Oh, that's a great idea. That's a good store. I really like this. That's a good story. So let's say you go to that amazing place and you decide to buy a pair of shoes. Well, you pick out your pair of shoes and you go to the cash register and they ring you out. Well, that information is being captured, and all that information you might just think is a pair of shoes, your credit card, and you go home. Well, the reality of that is far, far greater than that. They're actually capturing all of the attributes that go along with that pair of shoes. The size, what color it is, what box it's in, where that shoe came from, where you came from, because it's got your credit card information, All of that stuff is attached to that one point of sale. But if you decided not to go to that store and you decided to go home, stay home, and go online and purchase that pair of shoe online instead, there's even more information about you at that point. It gets super creepy now, I know. But your latitude, your longitude, your IP address, how long you stayed on a page, how many times you flicked around on different items, how long you left that item in a basket, how many times you took it out of your basket, how long it took for you to actually push buy, and then once you've pushed buy on that credit card, how much information we have about you on that credit card. All of that is big, big data. Think about the stuff that you buy online. Think about how many people buy stuff online. That becomes huge, huge information. And all of that has to be captured somewhere. Oh, thank you. Why are they collecting this information on us? Because it's really easy to do. And it's extremely valuable. It allows us to do a lot of different things. It's very, very cheap. Disk space long ago used to be very, very expensive. These days, you can use a gig of information for about a dime. It's pretty inexpensive. And it's very helpful. We can do a lot of stuff with it. As a behavioral scientist, you can make a lot of predictions about people. And the more information you have, the easier it is to make more and more predictions about people. Learned algorithms. This is probably the creepiest thing that I can possibly think of, but it's probably the neatest thing too. Is anyone familiar with learned algorithms? Yeah? Okay, I knew it. I knew you guys were smart. Okay, so a learned algorithm is a little bit more complex than an if-then statement. So if this happens, then this happens, right? So that's pretty logical. Well, a learned algorithm is a little bit more complex than that. It's strategy. It's how to write a program that can strategize based on a number of different scenarios. And it becomes smarter and smarter with the more information that you give to it. The more scenarios that you play, the smarter that it actually gets. So my computer, actually, I have a little sidebar on my computer right now, a little ad that pops up on my emails. I bought a hat for my friend's dog the other day. It still thinks that I have a dog. So I have to click out of that ad to make it smarter to realize that I don't have a dog. Like, it's making me nuts. I really want to get a dog now. But, sorry. Now I don't know where I am, sorry. Oh, and then, of course, making products more efficient. So if we're looking at collecting information, especially on machine data or the Internet of Things data, then it is pretty easy to predict when things could go wrong. So if condition X, Y, Z happens before something breaks down, we can have a pretty good idea on when to anticipate when we should send someone out to go examine a wind turbine if a certain scenario was present. Or for medical devices, same thing with that. And so that kind of goes back into improving quality of goods and, of course, people's lives. More importantly, people's lives. Let's take it back to that. And then, of course, marketing. From a business perspective, if you wanted to look at behaviors and patterns in people's behavior, then big data is amazing to use for marketing, of course. Thank you. So even though big data is super amazing, of course, there are major issues with it too. There's so much of it that even though it's really cheap to store it, we don't know where to put it at this point. We don't even know how to scoop it all up and put it into spots where we can actually use it. So the International Data Commission has estimated that we are only collecting and storing 3% of all the big data that's possibly even out there. That's pretty crazy. And then even of that 3%, we're only using 0.5% of the information that's there. So we're not even using it. It's pretty much, and I'm glad that y'all are all in the room, so hopefully y'all will be able to process some of this stuff so we can actually start using it. Another idea that's out there is that people who are using big data have the potential to punish people for the predictions that it's making. So a lot of people with criminal justice are saying that it's profiling people, that that they're putting communities in danger, saying that they're saying that based on the history of X, Y, and Z, that this community is probably going to react like this, and so they're putting certain restrictions on them, and that can be very sticky. And then I feel like sometimes I'm working my way out of a job. So when you automate processes like the way that we should be, because computers are computers and it becomes very easy to do that, it kind of feels like you're making a way to get yourself out of a job. But at the same time, I always like to go back to the idea that you really do always need those people there. And I always think back to the idea of Google saying that they were better at predicting H1N1 virus compared to the CDC, right? So everyone's familiar with that one. Well, this was in 2013, and so a year later, I mean, because the CDC is so archaic, right, with their epidemiological methods, shame on them. But a year later, in 2014, they went back and analyzed it and said, actually, Google, we actually did a better job at predicting the flu outbreak than you, and pretty much all you did was predict winter. So congratulations on that one. So really, you do need the human interaction, not only for the analytics part, but for interpreting that data too, and it is equally as important. So there's some holy crap facts that I just think are phenomenal that I thought I would throw out there before I start getting into some tools. 2015, the global internet traffic was 4.8 zettabytes. I mean, what? I don't even know how to so if I'm doing my math right, that's 48 billion terabytes, right? What? What in the world? I have a terabyte drive at my house. I call it my terabitch just because it's huge. And you can't fill it up. You cannot fill that thing up. But 48 billion of those, I just can't even wrap my mind around that. That's incredible. There's 400 million tweets a day. I've even seen that number say 500 million a day, and that's incredible. That's an incredible amount of information. Think of all the hashtags. Think how queryable that would be. I like queries. Facebook is putting out 100 terabytes of information a day. I'm sure that's super quality stuff. And then Google is putting out 200 million queries every single minute. And I'm pretty sure that I'm at least 100 of those a minute because I am a Google fanatic. So just to give you some perspective about the information that's being put out there. So we've got some big data software that exists, and I would be failing you, I think, if I stood up here and didn't mention some of these tools. Hadoop. Hadoop is an Apache software. It does two things and only two things. It stores and processes information on a really friggin' huge scale, bigger than you could even imagine, because it does as big as you want. And the way that I think about this is kind of the analogy that I was just giving you before about the brains. So how amazing would it be if we had more than one brain attached? Kind of works like that. So let me walk through this. This is how I walk through things. So if I had a stack of papers, and those stacks of papers had dates, just all kinds of random dates on them, and I gave that stack of papers to you, and I asked you to go through them and find all of the years that had 2012 attached to them. I want you to count them and tell me at the end of, at the end of the year, because it's going to take you that long, how many you found. You do that. So he's one processor, that's one computer, right? Well, it would be really great if I took that stack and distributed that stack to the entire front row, broke it up between them and said, now all of you count within your stack and tell me how many 2012s y'all come up with. You process it on your own. I want everyone to keep that, store it yourselves, keep it, and count it, shrink it down, and then give me the answer back. That's gonna go a lot faster, right? It's pretty conceptually, that makes sense. It doesn't quite work like that, but that's how it works in my mind. So the reality is they're human beings, and that's gonna go faster because they're humans. But if they were computers, I would make copies of that giant stack of information, and I would give them all the same stack. But then on my end, I'd write some JavaScript. I would geek out on my end, but I would distribute the work differently. I would say you all have the same stack of paper. Everybody's got the same stack. but I want you to all look at it a little bit differently. I'm going to say you look at the first month, you look at the second month, you look at the third month, fourth, fifth. Distribute the work a little bit differently. And that's really what Hadoop does. So it works on two levels. You've got a storage process, you've got a storage zone, and that's called an HDFS, Hadoop Distribution File System, for if you're dying to know. And then you've got the processing part, which is called the map and reduce. And so you can map it out, give it to all you guys. They're going to shrink down the problem, they're going to reduce it, and they're going to deliver a product back. And that's really what happens. It's pretty cool. And it all happens very, very quickly. And the great thing about it is if this computer dies, it's all backed up on the rest of them. So it's pretty secure stuff. So one of the catches with this is that you do have to know a programming language, but fear not, if you are not a programmer, you don't have to know a programming language. So if you know like SQL or something, you can download one of these translatable things like Pig, Hive, Flume, Scoop, Uzi, Impala, one of these guys, and use whatever language that you do know and overlay it on top of Hadoop, and it will translate your language into a map-reduce language for you, and then send your query out to all these computers, and then get your answer back to you. So it's actually pretty cool. Let me get out of the way so you can take a picture of my amazing slide. So there's a company out there, it would really suck a lot if you had to download all of these by yourself. So there's actually a company out there called, I think it's called Cloudera. It's like Cloud, ERA, and Cloudera. Am I saying that right? I am? Okay, thank you for knowing. What? Do you? Okay, well, I'm going to call it Cloudera. I don't really know how to do it, or how to say it. But Cloudera actually puts everything, Hadoop and all of these other packages, the translatable packages, into one downloadable, amazing gift package for you, and you can just put it all in one thing and just do it one time. So it's actually really nice. So if you want to geek out on some data, that's what I would download. And it's free because it's open source. You're welcome. If you have access to big data anyway, that's what I would do. So I should also, I think, mention here that Hadoop is very, very different from your traditional capturing, so SQL versus no SQL, right? I love SQL because it's organized and it makes sense to me. I just love it. Hadoop is unstructured. It's a giant data dump. It's like a junkyard. You can put anything in it. You can put pictures in it. You can put emails in it. You can put blogs in it, newspapers online. Any kind of information that is on the internet can just be dumped into Hadoop, which is super, super cool as long as you know how to write the code to get that information out. So that's a no SQL world. But in SQL world, as I'm sure most of you are familiar with, everything has to be kind of structured before you put it in. So everything has its own nice, neat little box, which is very nice for me. I like that. And everything's joined together using different join statements and stuff like that. So everything's nice and clean when you put it in. Everything's nice and clean when you take it out. But it's also very restrictive. Everything's very structured. You don't have kind of the liberty that you have in the big data world. But after you're doing all that, you extract all the data that you want. There's different kinds of softwares that you can use. I happen to be a software snob, and I just use the two that I have listed here. I like SAS and I like SPSS for a number of different reasons. One, because that's what I was trained on, and I don't like change. I'm really saying a lot about myself, aren't I? But the unfortunate part about them is that they're very, very, very expensive. If you're a student, you might get it for a couple $100. If you're a professor, a few hundred more. If you're a small business, just don't even bother. I mean, really. You can spend up to $20,000 on one software packet for one license. So it's pretty significantly expensive. But they're huge advanced analytical tools that you can use. They both use command languages. So if you know command languages, that's pretty great. and their graphical user interfaces as well. It's all written in Java, but the scripting languages are R, Python, and Sax Basic. And then of course, SAS language has its own, or SAS has its own language as well. If you don't want to spend $1 zillion and you do want to do advanced analytics, I highly suggest these next two, which would be R and one called NIME. Am I saying that right? Does anybody know? Really? I've done my job. Okay. So I'm calling it NIME. I've also heard it called Naim, but I'm calling it NIME. So R has a lot of benefits. These are huge advanced analytic tools. They can do a lot of stuff. R is kind of annoying. I don't think it's very user-friendly. If you do, they're open source, they're free, and they're updating all the time. I think they're phenomenal tools. I really, really do. R, I don't think, is a very fun language to write. It comes from a language called S. Who's ever heard of that? Not me. I don't even know it at all. I looked into it, didn't care about it, so I learned R. I forget R all the time, luckily. Since R is open source, that there's a lot of videos out there on YouTube. There's a lot of resources out there that you can download and ask the community on like, how the heck do you do this in R? And pretty much anything you can think of, you can Google and find out. And it will be locked into the big data world forever. And NIME is pretty great. I'm just now starting to get into it. I've only been using it for 2 weeks now, but it's a pipeline format. It uses nodes. And so you can import, transform, and export all of your data using nodes. And it's just kind of a cool, it looks really cool anyway. And both of these are incredibly beautiful, actually. Yeah, I think they're really fun. So if you're interested in getting some information for yourself with regard to data, these are huge, huge, huge data resources. They are not big data resources, but they are giant data sets. Anything from finances to social media references, all kinds of data are in these two websites here. It's Data Science Central can get you there, and then R Directory or rdir.com can get you there too. And then I wanted to end talking about data visualizations, because I've never really cared about data visualizations. I'm kind of the person who's like, just give me the raw data and I'll picture it in my head. But as I've gone through business and talking with people like pictures, right? So I don't, but most people do. So you have to be willing to be okay with that. So if y'all are like me and don't really care about data visualization, you probably should learn. So I'm starting to really get into Tableau. I think it's got a lot of opportunity. I like it a lot. But R and NIME have probably the best data visualizations that I've seen in a really, really long time. So if y'all want to geek out on those two things, they're free. Get after it. Play with some big data sets from this guy, and continue taking classes like this or seminars like this, and I think y'all will be just fine. So I will take some super easy questions now. Nothing hard.
Okay.
If you're going to ask a hard question, I can tell.
Yeah, it's kind of on his face.
It is.
I'm just going to bring you a microphone. Quick tip, when you get a mic, it's on green, because green means go.
Green means go.
Green means go.
I just wanted to to see if you knew about RStudio, which gives you the GUI for
yes.
R.
Thank you, thank you, thank you. Yes, if you do download R, do yourself a favor and download RStudio, for crying out loud. It's mo better.
And Python also has a huge set of libraries for you to use for data analytics as well.
Yes, thank you. Thank you for saying that. I meant to say that, yes. You didn't even ask a question. I love you. Thank you. Oh, you were going to say the same thing. Dang. Okay, then.
This is actually a pretty simple one.
Oh, God.
The PowerPoint presentation that you've got up here, is this online someplace like on
it can
like
be.
SlideShare? Or?
It can be. or I can give you my card and I will happily send it to you.
Yes.
Okay.
And I'm sure I'm not the only one.
I did not source anything at all, so I stole a lot of it from online, but yes.
Okay. And may I squeeze in one other? As far as the Hadoop data, is that you said something when you were talking about it, which I wasn't sure if I was understanding right, but I took what you said to mean that essentially that this is something that's potentially centralized and accessible, as in like something along the lines of like repositories, available for aggregation or API interfaces.
It's really how the person sets it up. So you would use Hadoop, like if you were Google or something, you would use Hadoop to set up the data collection, but you would have those computers available for the distribution of that information.
Well, what I mean is essentially for, in other words, people in this room.
Oh, getting that information?
Yes.
Oh.
In other words, is it proprietary or
Yeah.
is it accessible?
So I would say both. So there are sites like the ones I just shared with you that you can get a lot of that information, but I mean, Google's own, Amazon is another huge data bank, I guess, that has a lot of their information, but they put it in packages that are found on sites like the ones I was just sharing with you, that they put it in kind of clean packages for you like that. But as far as I'm aware, is anybody else aware of a place that you can go get like LinkedIn? Yeah, that's another one. Yeah. Yeah, that link, that's actually been embedded within one of the links that I shared with you. Yeah.
Plus, R has a lot of library sets out there that have data already in them. If you want to just play with small data, at least for your first few things, then you can grow bigger as well.
Yeah, and that's also embedded in my. Oh yeah. Oh yeah, yeah, exactly. Yeah, that's a good one. Yeah, that's a really good. I don't think I had that one up there.
Coursera has a nice R tutorial class that's free if you don't want to get certified.
Yep, true.
Can you tell us, without getting in trouble, some of the kind of analysis, an example of a project that you're working on these days? Just examples.
Do you mean at work or for my private business?
Yeah, at work.
So I'm still very new there, and so I'm going to say no, that I cannot do that. But that would be an interesting conversation to have. Yeah.
So where do you see like big data going between like medical, the world that we live in, say for UAMS, and like consumer behavioral?
That's a good question. I would say that if we started utilizing big data the way that we could use it, like if we started capturing more than just 3% of what we've got, especially on the medical side of things, then I think the potential is endless. I think we could probably have much better healthcare, not with regard to just medical devices, but I think with regard to predicting better insurance plans, better disease predictions for people altogether. And so I think it's limitless opportunities with regard to health. I think on the other side of things, gosh, I don't know. I think there's just so much potential out there. I mean, we're only looking at 0.5% of stuff right now, and we're already making landmark decisions, I think, already. So,
like, do you see people in the future saying, if you eat Greek yogurt, you'll die of this disease?
Probably. I mean, yeah, really. I mean, yeah, really. People will make assumptions like that. But then I think it comes back to people with the know on how to interpret assumptions like that. So your experts, like your epidemiologists and people who can say, let's not get crazy, folks. I mean, Greek yogurt can be good for you too, you know. You're always going to have two sides of an argument, but I mean, yeah, you're gonna have quacky people too. That is the name. So for the record, he just said correlation doesn't mean causation, and that is the name of my network, or my IP at my house. I'm not kidding.
So kind of following on what he was talking about, I mean, the fact is today, a lot of us are starting to wear these little things.
Yeah. Oh, yeah.
And Apple just today announced CareKit, which is a tool to go and collect stuff from the Apple Watch and pump it up and everything like that.
Oh, cool.
So the question I've really kind of got is, we're now starting to collect a lot more information from these things. You came from the medical field and things like that. Could you give us some examples of ways that kind of translates along these lines? I mean, because you're right, there's lots of data coming out there, but what did you do as you went through the UAMS process? I mean, there at UAMS and kind of helped out the researchers and things like that.
So I'm going to take that back one decade. So historically, where big data came from, so 90% of the big data that we have now has been created in the last 2 years. And I think the reason for that is because where we got big data before was companies paid data enterers to sit back and enter information into the computer, and that's where we got it. Since people have started using devices like that, now everybody's putting in data. Data is like exploding. So, I mean, yeah, I'm coming from the medical field, but I cannot even conceptualize where the heck it's headed. I don't even know. Kaiser Permanente's.
That talks about taking Fitbit information, plus their healthcare information,
merging it together.
All this stuff in their big data landing zone.
Yeah.
So it's a great case study on what they see healthcare.
Yeah.
And the data collection.
So the weird part about that is you've got a lot of biases that are introduced into that, given the fact that the people who have Fitbits are part of a different demographic who don't have, compared to those who don't. So, I mean, we have to look at that as well.
So can you, this kind of builds on that question a little bit.
Yeah.
Can you talk a little bit about what is missing out of the data set? So 3% is being collected.
Yeah.
0.5% of that is being used.
Right.
What else is out there that can either be used that's not being used, or be collected that's not being collected? And so part of the reason I come to this is in thinking about sort of uncovering trends that can help in terms of understanding legislation, help in terms of also it's very much a values and mission driven kind of
policy, where can policy be driven? Yeah. Right.
So, but you can't use it if it's not being collected. If it's stored someplace and nobody can analyze it. Then,
sure.
So can you just talk about what's missing there?
Yeah. So with regard to the 2.5% of the 3% that I was referring to, I have no idea. I don't know what that 2% is. I wish I knew. I'm still looking at it myself. But with the other 97% that we don't know is being collected, a lot of that is coming from the machine data that we are collecting out there, all the black box information from airplanes, all of the train information that's being collected, which is over 900 terabytes a day worldwide a day. I mean, that is, I can't even conceptualize that. And that's insane to me, but we're not using any of it. We don't even have a place to store it. So a lot of that's machine data right now. Yeah. That I'm aware of anyway.
Would you share your role and what you're doing around your economic data?
So I think we can do it much more, which is part of the reason why I'm here. So I work at Southern Bayport Community Partnership, a values-based community development financial institution. So part of what we are interested in is understanding and promoting economic mobility. And so, we look at people who are banking, who begin to think about, trends in savings habits, trends in even coming to banks and using banks, trends in moving from one type of banking product to another, how people move back and forth, those kinds of things. I think there's quite a bit of information there. And then we also do quite a bit of public policy work, which is sort of what prompted my question. Because it'd be interesting to know what kinds of data are out there that could be mined. My personal dream would be to be in this scholars and just do this stuff for fun.
I'll do it with you. We should start a business. Startup. Woo, woo.
So, thinking about what's out there and what's not being looked at, and there's quite a bit of, I think my guess is there's tons of information that would be really, really helpful, or really illustrative, if you had time to do it.
Yeah.
The other people who could ask those kinds of questions.
Yeah. I agree. Yeah.
I think it's just not a question, it's a comment.
we get into collecting data, but we really don't have any reasonable way of analyzing this data.
I know.
Even the algorithms are very outdated. There are few. Our community is very active, and they keep on creating their own libraries, because R was started by a statistician. I think 2 statisticians
It
started
was
with the
Ross and somebody else,
Yes,
another R
yeah,
guy.
yeah,
Yeah.
yeah. So both of them started, and then now the community is very huge. I think it is 2 million users, I believe.
Yeah.
And since it is free, and the tool is open source, so you will have some difficulty in installing. Sometime I see old version when you try to install the new one, old
Right.
library has, there are certain issues, but by and large, it is a very useful tool for at least people like us. I consider that I'm just a beginner in those world analytics. More than the data, I think the skill sets of the current, whether it is statisticians or IT folks, they are very low. They are not even reach a 30% capability or 20% capability. That is our basic issue. So we have to have good courses or training methods or some sort of things, because otherwise, just as you said, you can collect data. What do you do with them?
Right.
Just
Data means
lying
nothing
in
if you
your
can't
hard drive.
analyze it. Right.
And it's of no use. So
Right.
it's of no use. So making sense of those data is the biggest challenge. So there
Exactly.
are 2 ways. Only you have to get trained. You have
Right.
to have better algorithm exposure.
Yep.
That's all. It's just
Shove more of our kids into STEM.
Okay.
Are you going to ask me a hard question?
Uh,
Oh no, you are. What is it?
how am I somehow scary?
I don't know, but I'm scared.
Okay, well, and hopefully, the first thing that I was going to say is not going to make you even more nervous, because I was going to say that I'm hoping that I can broach this without it derailing things or being like a landmine.
I have braced myself. I'm ready.
Well, no, hopefully not. A few minutes ago back there, he mentioned essentially like, wearables, like we have with the,
like a
Apple
Fitbit
Watch and other Android devices and so forth, etc. The Fitbits and all of that other stuff.
Yep.
And essentially, that pairs with something which is currently going on, where essentially it gets into the realm of ethical and privacy concerns concerning big data and concerning access to what is available, what data is available through all of these portable devices that so many of us now rely so heavily on. There's, Apple's current privacy battles going on with the federal government right now.
Yeah, right.
And one of this is literally something that I just came across today. Was there was a mention of an article that I didn't even have time to read.
I know which one you're talking about. Yeah.
Essentially, it went into that. One of the things that Apple is starting to do with iPhone and with wearables is they are starting to collect biodata. And by collecting biodata and essentially like life logging, so to speak, you get into a whole other realm, which is HIPAA privacy. You are potentially collecting things that are going to be, personal medical information, to which there are really, really strict laws about it. And of course, I've seen HIPAA in action. I've been on the side of HIPAA, at least, on the IT side of HIPAA, but I've also seen it operate within organizations. And
So
I hate to say that. Huh?
What's the question?
Well, essentially, I don't know that I have a question, but rather I'm kind of commenting and also introducing another angle to this.
So Elizabeth,
I'm sorry?
who owns the data?
I'm not a lawyer, I don't know. But I mean,
I don't know who owns the data either. But as a health professional, yes, we could get into those types of questions. However, when you sign up for a Google account or a Facebook account, you're putting your information out there. When you sign up for a Fitbit account, you are putting your information out there. I'm not saying that they should be looking into it, but as I am not 100% for sure of your question as well, but
we also have to understand what bioinformatics are. And so that can be anything from age to weight. It doesn't have to be like your genetic makeup, you know.
Every company that deals with collecting data and bringing that needs to have a strong privacy and legal evaluation.
Yeah.
One of the major things that we do is as new data comes in, we have to evaluate what's in there. We actually have to get it changed. You said it's going to be this, but now you're putting a social security number in that.
Oh, Lord.
And we don't know about it. So we actually do evaluation of every file. Does it look like the last file? The same number of.
Oh, your Axiom. Yeah, you do that. Yeah. You actually do that. Yeah. Yeah.
And we have a very strict privacy. A lot of companies don't, are going to get in trouble.
Right. Yeah.
But as you put this stuff together, you have to ask those questions. As you go through Hadoop, you have to ask, how do I secure this to make sure it's just not an open playground?
Right. For everyone to grab.
Which is the standard default install. Anybody can grab anything off of it. And you spend all of our time is figuring out how to secure it to make sure that we're doing that.
I mean, you've got doctors' offices that now use electronic medical record systems, and those get hacked. I personally had it happen.
Yeah. Yeah. No.
well, I have one more comment, if you don't mind.
No, please.
You know, as you were saying, you're a quantitative researcher, which I think most everyone here is. I'm qualitative. I'm a people person. And so much of what you were saying was talking about the individual, the person, and you, well, I don't know where that guy went, but it's individual. Like if we choose to put our information out there, we choose to put our information out there. And yes, we have to protect them. And yes, we need to make sure that everything we put out there is correct and able to be analyzed. However, you know, it's all about people. I think that's what Dr. Childers, well, actually, no, I guess not. Like, she doesn't think it's all about people. But all of the
am a terrible
information
person. I
out
shouldn't
there
say
is from people. It comes from people.
It does. It does come
On a
from people.
Likert scale.
Well, mainly just a comment that since we're in this entrepreneurial community here, and that's kind of aside from the technical aspect of our talk tonight, this is an entrepreneurial venue. You mentioned Fitbit accounts. We mentioned Google accounts. As those companies and the companies that some of you might be considering starting, as you're developing applications and systems that consumers will use, the valuation of these companies is way overbalanced toward the value of the information they have on their users.
Well, absolutely.
Not necessarily how many users they have or you know, how many ads they can flit on the screen.
Could not agree more with that. That is absolutely the truth.
So it's the quality of the data. The quality of the data determines the value of the data.
Or just the fact that they have data, that they hang on to the data and they can tell someone looking to purchase big data,
Here's a good example.
here's a population, this is what they do.
Here's a good example of some of the Republican will make more money selling their list of donors to others. They continue to make money on them. Where does that money go to? Because it's supposed to go into the campaign, and where does that?
I'm officially out of beer.
Continuously over multiple years, even though their campaign shut down, selling that leasing, they don't sell it, they lease usage.
So the other thing I just wanted to add to that, because I think all of that is correct, but I think part of the reason this is an issue, and it's back to the people question, is we have created and allowed a society in which a lot of the we sell what is free, we buy what's free with our data. And so that's been a decision with the way the business models are designed. There's not necessarily anything wrong with that, but that is part of the equation, right? So if folks were willing to pay for certain kinds of things, then there might not be as much data collection. I think as we think about the role of ethics in that, as we think about privacy issues, that has to be part of the question. It's not going to be free without, it's not really free, right? So you're paying for it with something. And so you're paying for it with your data. That's exactly right. You're paying with your data, and we need to acknowledge that. And that's part of the answer to that question around privacy. That's also, my guess, is part of the answer around the ethics issue too.
Awesome questions, you guys. Thank you so much. Can we give a big hand to Elizabeth? Okay, so since you're here, and Andrew is going to pay extra special attention to this part. You're totally paying attention. You're fine. Don't panic. Okay, so I want to know what else you guys would like to talk about, big data or not, for future Codits. Like, what is a really cool thing that you would like to hear about? Stellis.
Maybe on a hands-on, maybe you can to do a particular tool, a demo, but it will not be over the 1 hour. Just like what I did for a security session.
Yes.
It might be a little long.
Yeah.
Because this is really get a whole
right.
overview of the whole thing, so we can dive a little deep, a little more. Maybe select a particular tool and do some examples.
Okay.
Practical and useful.
Okay, great. So a little bit more hands-on of something interesting. Okay. Yes. Okay, caching systems. Awesome.
I don't know if everybody knows like how advertisers basically use the data to market. That's something I do.
Okay.
And, all of you talk about privacy, what people can look at advertising.
Right. Okay, so how data is used for advertising, essentially. Axiom. All right. Anybody else? Like, what would you like to get really deep in the weeds with?
I think what would be really useful is to find ways to experts to create system so to have those conversations about how would you use like marketing data to create some kind of software product.
I think that is a perfect cue-up, Jess, for you to talk about 2 days to start.
Right.
And the mayor's open data.
Right. Okay. So yeah, we are actually doing a 2 days to startup program, which is a little bit like a startup weekend. If you've ever heard of that, it starts in the evening on Friday, rolls all the way through the weekend. Although unlike the hackathon, you are totally encouraged to go home and sleep. In fact, I will lock you out. So you must go home or at least not stay here. And the whole idea with that is that it's to show you what you can do to take an idea and turn it into a minimum viable product over the course of a weekend. And it's an amazing time. This one that we're doing specifically ties in to the Smart Cities Initiative and the What Works program that the city of Little Rock recently announced that they're working very hard on. In fact, Trey Bowles, who is the CEO of the Dallas Entrepreneur Center and kind of spearheaded the entire Smart Cities initiative in Texas and some other places as well, is going to come and talk about how there are opportunities to use smart city style APIs that are available with open data cities like Little Rock. And we're going to give you some examples at this event of opportunities that you have to access data from the city and turn that into something that can be commercialized.
One of the cool things is a lot of crime data is in there. It's not all aggregate. There's really cool raw data. You can actually build some models to predict where crime is going to happen in Little Rock and a whole bunch of other stuff. The users of the software could be anybody from the community or the offices of the city. So the building analytics tool for the police chief.
There's a lot of profile there now.
Yeah, there's yeah. Anyway.
So it's all based on the data that's in there, right? And we'll work with you, and Elizabeth will come in and mentor you on the do's and the don'ts.
Right. Yeah. It's not all about crime. There are lots of things in there about potholes and opportunities to, you know, fix other things in the city. So not just crime, because Little Rock is a lovely place to live. Well, that's the other thing. We should have somebody from IBM's Watson team there as well, talking about some really cool cognitive APIs that Watson has. So if you haven't heard about those, you'll get to hear a little bit more about that. But circling back to Code It, and the next one, we're still hammering out dates with our speakers. It's probably going to be the 4th Tuesday, but I may have to move it to get the right people here. I should know that this week for sure. But our plan for the next Code It is to have a debate / argument about iMessage encryption, how it works, what are the legalities involved in that, how it affects, you know, the users, the coders, the people. So anyhow, oh, May, remind me, May.
Okay, so we're doing a joint Code It with the UALR and Emerging Analytics Center.
Yes.
The guy that's coming, I can't remember his name, but he built the Navy's Human Simulation Research.
Yeah.
So he's going to talk about how the DoD and the Navy actually simulate all sorts of really cool stuff. He's a national speaker, and he's going to have some cool demos for us to look at.
Yeah, and our equipment should work because our AV guy has now been shamed. And so, anyways, we do love him. I'm not going to tell you who he is. All right, so I think that pretty much wraps us up for tonight. We need to give another round of applause to our awesome presenter. She said